So this is going to be the reactions of strong acids, and weak bases in water. We've already done salts, which are electrolytes. Now we'll do a strong acid, which is going to be a strong electrolyte also. So a typical strong acid, let's just pick H2SO4. And we know, because we talked about it, we put an aqueous in here, plus water. We're going to react these with water. Acids and bases react with water. Salts dissociate. And this goes 100%, and it's called ionization because we form ions. We react to form ions. And what we get out of this, and you should know this already, the oxygen grabs a hydrogen. The oxygen on water grabs a hydrogen from the sulfuric acid, and we get two of these H3O pluses because there's two hydrogens over here. Each one can form an H plus, and we get a sulfate ion, SO4 minus 2 aqueous. So this is a reaction. Two things are reacting together. It's called ionization once again, and we form a strong electrolyte. These are ions. It's a 100% reaction. That's what a one-way arrow means, and it's going to form a strong electrolyte, which I abbreviate in the homework SE, strong electrolyte. Okay? That's all there is to it. All your strong acids do this, every single one of them. Okay, so now the difference between sulfuric acid and a weak acid like, say, HF. HF reacts with water too, and I should put a liquid up here. I'll put it up by the water. HF reacts with water, and we'll put an aqueous here. That means it's in water, liquid. The only difference is this reacts 1 in a million. Every HF doesn't react. And we get H3O plus F minus over here, aqueous. It's why we call it a weak acid. It does not react 100%. So out of every million HFs, we might get 1 F minus. And so this is ionization, which means it's reacting to form ions, but it is a weak electrolyte because it doesn't react a lot. So we go WE and weak electrolyte. Both the strong acid and the weak acid are electrolytes. The only difference is a strong electrolyte and a weak acid is a weak electrolyte. Okay? And that's the reaction of acids in here. Now I'll do the one weak base. We already did strong bases. They're nothing but a salt. So weak base, WB for weak base, like ammonia, that's the only one that we know. We put our little aqueous in there. If you forget the aqueous, I don't care, but you should know it's there. H2O liquid. And again, it's a double arrow because it's a weak base. And so we get NH4 plus OH minus, aqueouses on both of these, indicating they're in water. And this is the 1 in a million. If we have a million NH3, we only get one here. So, you know, if 1 in a million, 1, 2, 3, 1, 2, 3, 1, well, that's 1 in a billion. There's a million. And this would be 1 over here. That's how it would set in a solution. It's not exactly 1 to a million, but that's the way to think about it. And so this is an electrolyte. It is an electrolyte, but it's a weak electrolyte, just like the weak acids. So weak acids and weak bases are weak electrolytes. They are electrolytes. And it is undergoing ionization. Ionization. Boy, blue didn't work out real well. Okay, and the last thing is a molecule. What does a molecule do in water? Something like sugar, it just dissolves. It ends up being sugar aqueous. It does not form ions, so it is called a non-electrolyte. So all your acids, bases, and salts are electrolytes. The sugar and molecules like CH3OH are they're just dissolve in water, they don't react, and they are non-electrolytes. And that's it for this